My name's Dan Hanks. I work for Adobe. I'm a system administrator there. How many of you know about Ansible already? A little bit? Yeah, okay. How many of you have used it? Okay, so my hope is this isn't too elementary for you. I'm going to start basically from the ground up, so we'll see. So Ansible is an IT automation tool. This just comes straight off the website. Use it for automating a lot of your IT tasks, continuous deployments or zero downtime rolling updates. Goals that it has is simplicity, ease of use, ease to get into, ease to get your team to start using it, using OpenSSH for transport. More information on Ansible.com. It's a project started by Michael DeHaan, who was the author of Cobbler and an older project called Funk, which I presented on also 6 years ago. It's been a while. Back when it was up at the thing in Salt Lake, right? Anybody here for that one?
I was actually at that.
Not bad. Sweet. Cool. Come full circle in. So yeah, just information on it's a growing project. Has a lot of contributors. A lot of people interested in it. So why use Ansible? One of the things you can do with it is what I'll refer to as command and control, which is essentially just taking a command like restarting your Apache daemon and blasting that out to a number of machines. So you can certainly do that. You've got a master. Say, run this command on all these minions and tell me what happened on all of them. That's command and control. You can do that with Ansible real easy. Another one is for structured command and control, which is kind of like what you can do with Funk, where instead of just saying one shell command, instead say invoke the service module and say we're going to deal with the HTTPD service. Make sure that that service is started and make sure it's set to come up at boot. You can spray that across all your minions. So that kind of moves us towards traditional configuration management, where you do a lot of that kind of thing. Where you say on the www servers, make sure Apache is started, set it to come at boot, spray out a http.conf, use this template as a source, and make sure the HTTP packet is installed, make sure it's the latest. Similar for the database machines, make sure MySQL is started and running. Configure it using this template. Similar for memcached and so forth. So you can also do that with Ansible. So here's where I think Ansible really kind of shines, is on this idea of orchestration. So consider this environment where you have one master, we have a load balancer, some web servers, a database server, and a memcache server. Pretty typical configuration. And you want to be able to run a schema update. Consider like a deployment of some software, like a production deployment. You want to update your database first, and then remove half of your web servers from the load balancer rotation. Stop Apache on those web servers, deploy code to them using Git, and then start Apache back up on them. Put them back into rotation, then remove the second half of the web servers from rotation. Stop Apache on them, do the code update, start Apache back up, put them back in the load balance rotation, and then restart memcached, maybe doing a rolling restart across those memcached servers. Ansible can also do that. We'll look at that's kind of where you start to see some of the power of what you can do with Ansible. And all this happens via SSH. You have no agents to install, to manage, to monitor. It's all straightforward. So some of the advantages, again, talking Ansible uses SSH as its transport layer. You don't have any additional and possibly questionable authentication mechanisms or security models to worry about there. There's no root access. If you're in an environment where you don't have root access, you can still use Ansible. It can use sudo, password keys. You can SSH to different users or any combination of the above, whatever your SSH infrastructure looks like. So that's one thing that's really I found very appealing to me about Ansible, is that I didn't have to rethink my authentication, my IPA infrastructure to deploy this. It could just ride on top of the system that we already had in place. There's no agents, no daemons involved. Which means there's fewer moving parts. Nothing that you have to monitor out on the minions. You only have to install it in one place. So that means that upgrades are trivial, and it's easy to run this thing out of just a git checkout. The configurations are very readable, very approachable. You don't have to learn some domain-specific language like with some of the other configuration managers. It's got a very low barrier to entry. It can be as simple or as sophisticated as you want. And this last one's a little bit of a dig against SaltStack. I really don't have anything against SaltStack. Salt's a very capable tool. Just some of their semantics kind of drive me crazy. Trying to remember what's a grain, what's a pillar, what's a reactor. Anyways, Salt is a very capable tool. I'm not going to dig it very much more than that. And the other nice thing about Ansible is for the core, there's very few dependencies that you have to install to have it actually up and running. That was also very appealing for the use case that I had in which I wanted to use it. So we're going to talk about installing it real quick. On the master, you just need at least Python 2.6, a few modules, Paramiko, which provides the SSH transport layer, YAML support, Jinja 2 for templating, and then HTTP-lib for fetching, making HTTP requests. On your minions, you've got to have at least Python 2.4. If you're less than Python 2.5, you need the simple JSON module. Although if you're just going to use the raw module, you won't even need that. And other modules, like some of the big IP or the cloud modules, require other dependencies. So depending on what your needs are, you may have to install some other things. It's very easy to install and use. The very most basic. Just do a git checkout, git clone, cp ansible, run this env setup, and you're ready to go. If you want to do a little bit more package-wise, enable the EPEL repository on Red Hat tile systems. Yum install Ansible, RPM. You can just cd into Ansible, make RPM, and there you got an RPM out of it. If you do from the git checkout, apt, FreeSB package ports, homebrew pip. And you're done. No agents to install anything else. That's it. You've got it installed, ready to rock and roll. Create an inventory file, and you're good. So let's talk about, now that you've got it ready to go, just some basic ad hoc invocation, like we're talking simple command and control. Bet you weren't expecting that. Okay. Basic invocation looks like this. You say Ansible, you give it a host pattern or a target pattern of the host that you want to target in your invocation. Pass -i for an inventory file, or you can set an environment variable, I think it's called Ansible hosts, to point to the file that contains your inventory. There's some other methods we'll talk about later. Specify what module you want to invoke, and then what arguments to pass to that module. So for example, run uptime on all my hosts. You use the special keyword Ansible all, get my inventory file, run it through the shell module, which runs your commands through a shell, so you have things like pipe and redirection you can use. And then run the uptime command. These are the arguments you're passing into the shell. Run that. Another example. Run Ansible without arguments for usage information. Let me show you that. And I'd recommend doing that. Let's see. Oh, yeah, good. Nice. Let's try that again. While we're waiting for this, you guys heard the one about you have a hi-hat and two tom-tom drums go walking and fall off a cliff? All right. Yeah. Hang on a sec. Make sure I've got the right host name here. Oh, there we are. Never mind. Okay. Just run Ansible, and you have, okay, as I was saying, cd to Ansible. So I've got here, I'll just give you a little background about what we've got here. This is just a Amazon host, and I've got lots of latency. So what you can't see, and hopefully you can now. Okay, so we've got a directory called Ansible. This is where I've done a git checkout of the Ansible code. So I cd into Ansible. I do dot or to source hacking env setup. Oops. And I can't type when everybody's watching. Come on, latency. There we go. That sets up your environment. Puts Ansible into your path, sets up your libs like you need. And now we should be able to run Ansible. And you get all these wonderful options, this huge list of options that you can then use. I highly recommend looking at those, because those tell you all the things if you need to use sudo, if you need to sudo to a user, if you need to log in as a user and sudo to another user, if you need to sudo to root, if you need to sudo to root, all of those options you can do with Ansible. Okay? If you need to have Ansible ask you for a password, if you're using password authentication, you can do that too. If you need to have it ask you for a password to get to sudo when it's going to sudo to a user, you can do that too. All of the above. So, let's see. Back to our slides. All right. Where were we? Oh yeah. So Ansible all, give my inventory file, run shell, run uptime, use sudo. I want to sudo as, I want to log in as this other user, and then I'm going to sudo to this guy, and then ask for the password to do that. So just an example. Oh yeah, I've got a video in here before. I should read my slides, huh? Okay. And just about any other combination of the above. And I've just been really impressive to see how well Ansible has handled all of the situations you could probably think about to use in your environment. So for some more examples, this one, run a command through a shell, use the shell module. Here's your command. Oops, I forgot closing quotes. Grep total info, for example. Run a command not through a shell. You would use the command module, which just runs a command, doesn't put it through a shell, so you don't have pipes or anything available to you. Command SNL config. You may have different needs for that. Raw module is kind of useful. For example, if you want to run commands on your routers, I've never actually done this, so I'm curious to see how it works. But it doesn't. What normally happens in something like this is Ansible transfers a bit of Python over to the remote host and runs it to do its thing, so it can give back the output and everything like that. In this case, it just funnels the command over the thing and grabs the output that came back. So you can throw this to your routers or other devices that support SSH, but maybe not Python. Okay. This one's kind of useful if you have a script that you want to run. Ansible run all my scripts, all my hosts. Use the script module, and then take this, which was on your local machine on the master, copy it out to the minions, and run it out there. Okay. So that can be pretty useful. In the inventory file, it looks kind of like this. Okay. Here's where you specify hosts, host groups, and variables that can be associated with those host groups. And we'll talk about why we need variables later. That comes in when we're talking about configuration management. You can have just bare host names in here, like this. And then you can create groups, kind of any style files. So I have a set of web servers, a set of mail servers here, and then you can also do these nice expansions. Wildcards, I think, work as well. If you have a lot of the hosts that are named using a similar naming pattern. So, for example, I could say Ansible web, and we'll talk about these. This says web or FTP or mail. Let's run this on these hosts or these hosts or these hosts. Kind of ORs it all together. Now let me clarify. Run this if the host is in this group, or it's in this group, or it's in that group. That's a little more clear, right? But, use the shell module, add it to Red Hat release, whatever. Okay. So host variables can be used to set connection attributes. And you can set these variables either on the command line. Excuse me. This is inside your inventory file. So you have a host here, and we want to say always SSH as user Rob, and also use this Python interpreter once you SSH over there. So this is useful if you have hosts that, for some reason, the default Python is not Python 2.4, and you want to use some other Python that Ansible does support, since all it's somewhere else. You can also use host bars to make aliases. So just www always becomes www.example.com. So if you want to give some shorthand to your command line, you can do that. And then here's expansion. You can set vars for all the mail hosts this way. So you've got the mail group, and then the variables for the mail group are always use SSH port 5555. And there's a lot of different variables that you can set depending on what your needs are and however your environment's set up. This is groups of hosts. For example, we have US East might be www 1 through 5, US West is www 6 through 10. US All, its children, US All is another group, is the US East and US West group. So now you can target the US All group. EMEA might be www 11 through 15, APAC 16 through 20. Global's children is US All, it's this group, and you can nest groups, EMEA and APAC. So. And that should be lowercase. Make sense? Pretty straightforward. So the preferred method, though, and we'll talk about this a little bit later, is you can put your host variables in different files. So for example, if your inventory is in homely Ansible host, then Ansible will also look for, when it's checking targeting, this directory called group vars, and then it'll look for a file called group name. And then host vars, and then host name. It'll look at all those files and see if that matches any of your targets that you're invoking on your command line. And these files are just YAML formatted. They look like this. You got some variable, some value. We'll talk about direct. There's a whole directory layout once you start getting into configuration management and orchestration that Ansible recommends. Doesn't necessarily specify, and that's the nice part, is that it's really, really flexible. It can be as small and simple or as big and complicated as you want, and it can handle both the small and both the large and complicated really quite well. Once your inventory file is ready, you can select target hosts with patterns. So you do Ansible, pattern, and then options. So run this on all hosts using the yum module, giving these arguments. And throughout these examples, I'm trying to give you a kind of a feel for some of the different modules that are available. So this one's using the yum module that says, look, install this package, make sure it's present. So it'll go out and install that module for you. And using this all, you can use that to target all your hosts in your inventory. You can do a specific host name, and it says copy this local file out to this remote file. Do that on whatever host you specify. You can do a specific group that we saw in the inventory file, US West. Use the invoke with template module. Use this local template file. Ansible uses Jinja 2 as its default templating engine, and then make this interpolate the template and write it to that file there as the destination, right? Okay. You can also use wildcards. So start at example.com. This one's unarchiving. This thing is sent through .tgz into a remote directory. You can use, we talked about using the colon for or. So if the host is in this or this, US West or EMEA, and fetch that remote file and put it in the local directory here. You can use this to exclude. So if the host is in US all except not this host, right? Then run the synchronize, which is kind of like a wrapper around rsync. So synchronize this local directory with the one on the remote directory and do a recursive rsync. You can use ampersand for intersection. So for example, this one must be in the DB host and web hosts. So you can put that along there. Set this SE Boolean. Make sure it's set to yes. That's another module. And then you've got all sorts of combinations that you can do. I'm just going to leave those as an exercise for the reader. You can also do regular expression matching. So look for anything that starts with DB or WebDB, and then we have any number of 5 to 9 characters, 5 to 9. I invoke the MySQL module and make sure this database exists. Create it if it doesn't. Okay. All right, good. So basic idea for invoking modules, and if you look, let's see, I think I put the you're over there. Yeah, here we go. There's this long list and growing list of modules that Ansible has that cover all sorts of aspects of your enterprise and your operations. For example, this one says on all my web hosts, invoke the Git module, do a checkout or a clone from this Git repo, put it here, check it out into there, update it to this tag, force it so it overwrites anything that was in there, do a what do they call that, a shallow checkout, right? So you only get like the most recent history. So you don't have to get like 100,000 revisions behind it. And use this. We've got some special Git on our system or on the remote system, so you got to use that Git to do the checkout with. So we're going to do a live demo here of running Ansible. Hopefully I haven't lost my network connection again. Okay. So I have here this directory layout. No, wait. Yeah, okay. So we're inside the Ansible directory. Don't need to do much in there. And let's see, I have an inventory file. It's called inv here. It's pretty simple. It's just a bunch of Amazon hosts, which I provisioned with the Ansible EC2 module, by the way. I'll show you that in a little bit. This is the local host and the master that I'm running them on. A couple that I'm calling web servers, DB servers, memcached servers. Okay, really simple, straightforward for the purposes of education inventory file. Whoops. So what we can do, is, for example, Ansible all-m ping for the most simple invocation. I wish this wasn't so latency-ish. Come on. Oh, yeah. So it's going to bark at you if you don't have one specified in your environment, or if you don't have one in, it defaults to etc Ansible hosts. So, come on. Goodness. Had this been an actual demonstration. Sorry, guys. If you want the backstory, I think of my suspicion as to why we're seeing this. No authentication methods available. Oh, I know what's going on. I think it's, yeah. So I've got a specific private key I have to use between these Amazon hosts. So appreciate your patience here. Let's try that. And of course, we're going to have to accept all the host keys. And interesting. Well, we'll talk about the vault later. So we get a series of pongs back from each of these hosts, right? Okay. We can do, -m shell -a. Come on. That time. All right, there you go. Got enough time and everybody there. The reason these didn't come back is I've got some vault stuff going on. We'll talk about the vault a little bit later. All right. So you can also do dynamic inventory. So instead of using a static file for your inventory, you can write a script. So say if you want to interface with a CMDB or with maybe EC2 or Rackspace or some other cloud provider, there's a number of inventory scripts available that will query caller, EC2, Google Compute Engine. If you whatever you pass a -i, if it's an executable file, Ansible will run it for its inventory info. Okay. If -i is a directory, Ansible will run all the exes it finds in the directory and then combine their outputs. Okay. So you can have, I've got some hosts out in Amazon, I've got some in Google, I've got some in my own private cloud. Run all these, pull all the information back, and use that for your inventory. So you can use it to target all the hosts in these, some hybrid cloud setup you've got. Okay. It'll first run it with the --list, which should return a JSON dictionary of all your hosts, and then --host given the host for subsequent invocations to get more information on each host. And I'll leave that as kind of an exercise. See the docs. But that can be useful if you want to integrate it and don't want to manage, big, huge inventory files. So let's look at using Ansible with Playbook. So this, what we're talking about, was just basic ad hoc invocation, a little run command here and there. Now we're going to start talking about using what's called a playbook. They're designed to be human readable. They're written in YAML. There's lots of example ones in the Git code. Good idea to keep these in source control. You can build up a tree of reusable parts and pieces, or you can just have it in one single file, however you want to do it. Again, depending on your needs, you can go small to large. Each playbook has a list of what are called plays. It's like a sports analogy. And each play has a list of tasks. And then each play is mapped to a group of hosts as a role. And these are invoked with the Ansible playbook command. So here's a basic example. YAML, So you've got to make sure your format don't have any tabs in there or you'll be tearing your hair out. Tasks, give every task a name. So what's going to happen is this, well, let's see. I've got some notes here. So in these hosts here, you can use the patterns like we used in the command line invocation. And this host here tells us which host, when you run Ansible playbook, you just feed it the YAML file, and this will tell it which host that play is going to get run on. Okay, so this whole thing is called a play. And then you have tasks that are inside this play. This is a task, this one, and this is one. They have a human-readable task name, so ensure bind's installed. And then we're going to invoke modules like we were from the command line. So we're going to invoke on the DNS servers, make sure package bind of this version installed, make sure it's present. The nice thing is these names are human-readable, and you reference them in other parts, of playbooks by that human-readable name. And their output, the status of what happened with those plays are shown with that human-readable name, which is really nice. This one, we're going to use a template. It sources this Jinja2 template, stick that in named comp, and once you put it in place, run this command against it to validate it. Otherwise, mark that step as failed. So just maybe what you can do. And then let's say we have on our local machine, we've got some directory full of zone files that we want to synchronize over there. So we're going to use the rsync-a flag, --delete, into var named using from the local files, and then maybe we need to sudo to use rsync to do this because we're deploying them into root or whatever. So again, the synchronize module is just a thin wrapper around rsync. And this makes sure that bind is running, name is service is named, make sure it's enabled at boot, and running. So yeah, each task is just a module invocation. The one thing to remember is each of these tasks run sequentially. When you run a playbook, these go step by step. But they're designed to be idempotent. So you get the benefits of ordered execution, if you've ever run into that in Puppet or something like that, where all bets are off as to what order you think you're going to run in. But you also get idempotency. So you can run this any number of times, and it's just going to inspect the system, say, is this system in spec with this policy? If it isn't, do something about it to bring it to compliance with that policy. And if it's not, don't do anything. So you can run this thing over and over and over again until your system's come into compliance. Okay. You can specify different options at your play level, and then down here your task level options. And then you can have multiple plays per file. So you can kind of start to see how you can start to orchestrate this. So you can do some configuration action items on one set of hosts, and go and do something on another set of hosts, and then go and do something on another set of hosts. Okay? That's where you get into this idea of true orchestration. Okay, we need to talk about facts and variables. So inside your playbooks, you'll want to be able to refer to different variables, host variables, and you can do different things conditioned off the values of these variables. You can set up the variables like we talked about inside your inventory file. You can set them inside the playbooks down in a var section as a play variable. So vars for this play, memcached ports this, max connections that. Or you can include them in these files, kind of like we talked about. If you have an inventory file here, then Ansible will also look in at the Ansible host vars host name. If the host that you're targeting matches that, then it will include those variables for when it's running on that host. Or if the host that you're running is in this particular group, then it will apply the variables that are in this group variable file to those hosts. Variables also come from discovered facts, which if you run, let's just up arrow to, there we go. And then instead of running ping, we're going to run setup. This is just kind of an internal module that you don't use too often, but it's helpful to see what kind of variables are available, discovered variables are available on each host. You've got this large group of them that come from, like, here's, networking, what are the mounts that are in place, what interfaces are there, here's your SSH host key, you've got Linux, you've got your architecture, what kind of virtualization is going on, kernel information, processor information, interface information, disk information. A lot of the stuff, if you ever run Factor or Ohi with Puppet and Chef, same kind of information you can get here. So all of that can be used inside of your playbooks to trigger different actions. Yeah?
Is that actually run on the clients, or is that?
This is run on the minions. So this is the information that, so the master went out and said, hey, give me all this information, came back, and if we were to scroll back up through all this, you'd see this big, huge JSON object for each minion that was targeted in that invocation. And this is the information for each minion that you've got there. So as Ansible goes out to run that playback on each minion, it's going to run setup, discover all these facts, and then all of those will be available as it's running through the playbook. We'll get a little bit more into some of those variables in a little bit. Okay, you can also register variables inside your playbook. For example, if you want to run a shell command, and it will take the output, and you can register that output as this variable to be used later. And then later in the playbook, you reference that variable in Jinja format looking like that. And you can apply these filters, like take this variable, and there's this function called toNiceJSON that spits out a nice JSON representation of that. Or the YAML. If you have a list, so variables can be scalar, they can also be arrays, lists, or they can be hashes, right? So you can have really deep and complicated variable structures that you can play with inside your playbooks. If you have a list, you pipe it through the unique filter and you get a unique list. And there's a whole bunch of other ones if you look at the docs that can be used. Nice thing is called the Ansible Vault. If you have sensitive bits, like passwords or password hashes or keys, private keys, or that kind of thing that you need to deploy the host, but you don't want the whole world to be able to read it inside your manifest and inside your version control, you can put it inside this thing called the Vault. So Ansible Vault MySQL vars YAML creates this new empty or this new encrypted file. It'll invoke whatever you got set for editor, like Vim, and let you edit that file. When you edit it, write it out, it'll be this nice encrypted file. When you invoke YAML, here's some other ones. Excuse me. So you can then edit the file. That's supposed to say encrypt. Excuse me. It should encrypt. You can encrypt an existing file. You can decrypt a file. And then once you want to incorporate that into your system, you say Ansible playbook -- ask vault pass. Okay. So if you have, say, one of these encrypted files inside your tree hierarchy, like in your group vars or your host vars, Ansible will come across that file, will say, oh, hey, this is encrypted, it's got some flags in it, it says this is an Ansible encrypted file. They'll see that, and they'll say, okay, I'm going to need the password, the vault password. And so you can provide the vault password as you're invoking the playbook, and then it will have all those variables that were stored in that encrypted file will be then available for your playbooks to use. Okay, so we're going to do a demo on playbooks, and yes, let's see here. Control R is my friend today, right? Oh, come on. No, I'm not going to be my friend here. Oops. Latency is not my friend. Let's look at this file first. Okay. So this is a YAML file, a playbook I whipped up for this presentation. These are a couple options. You can tell your playbooks not to gather facts. The first thing Ansible is going to do on a playbook run is going to run out all of the hosts and do its fact gathering process. If you don't need any of those facts, you can speed up the whole thing by saying gather facts now. Accelerate mode, basically, it takes a little bit longer up front to set up, but is faster in the invocation. Because what it does is goes out and sets up some kind of like it doesn't use SSH for the transport, but sets up a queuing mechanism between the master and the minions. It can be a little bit faster. So in this case, we're going to set up a memcached server. So I'm setting a variable here inside the playbook. We're going to install memcached. We're going to put the config in place with the template, using the template listed here. We're going to make sure it's running. And then we've got this thing called handlers. And you'll notice here on memcached, when I update the config, I have this notify section that says invoke this command, restart memcached anytime you update config. And this handler here will get triggered by that. So the handler's name is restart memcached. This gets notified when we update the memcached comp, and then we do service name memcached state restart. So that's common, ignore that. Then similar stuff for the web servers. And I think what I wanted to show you mostly here is in the actual template file for the memcached config. So here I have templates, memcached sysconfig. So this is the sysconfig file that's going to get deployed from memcached. I have a number of variables that I'm referencing here. So the port is going to be this thing I called memcached port, which I set inside the playbook. I'm going to run this thing as memcached. We're going to have 1024 connections. These are max connections. The cache size is going to be this little computed variable. I'm going to take this Ansible memtotal MB is a variable that gets discovered when you gather facts as the total memory on the machine. I'm just running a little expression where I say take the total memory and subtract 100 megabytes from it, and that's how many megabytes we can allocate from memcached. Options -T for threading. We want to run it with as many threads as we have CPUs. Ansible processor count. And then, for some reason, we want to put this little secret that comes from a vault file in there, in the comment, for whatever reason, right? I just wanted to show how to use the vault. So, let's see if I can get the right invocation so I don't have to take forever to run this thing. This is bad. Okay, so we're going to do this. So we're going to invoke the playbook with our inventory file. I'm going to specify a private key to use, and I'm going to ask for the vault password. So I hit enter. It asks me for the vault password. I pass that in, and then it can go out. So I have in there, I'll show you in a minute. So first thing it's going to do is tells you, oh wow, okay, yeah. So it's going to run this play, and it's going to run on memcached servers. Now it's going to run out and gather facts from these machines. So inside that directory where I had all that stuff, I've got a host vars file, I think, specific to the memcached host, or group vars file, I think it was, that's vault encrypted. And it goes through, as it's going through, it finds that file and says, oh, I need that, and it won't continue if it finds hosts that are associated with those group vars, and those group vars are encrypted. So that's why, and if you give it the ASPAS parameter, then it can actually decrypt, grab those vars, and then run the playbook. Now it's going to go out and gather the facts. This thing's taking awful slow. My apologies again. There we go. So then it's going to run through each of the tasks, make sure memcached is installed, put memcached config in place, make sure memcached is running. Now we're going to do the play on the web servers. We're going to gather facts. Yes, now it's done it all. And then it gives you this nice little play recap of everything it did. Yeah?
So who's responsible for the variable interpolation, the master or the minions?
The variable interpolation, so on the template, all that interpolation is going to happen out on the minions when it's running. Does that make sense? Okay. So Ansible is going to ship all of this code and information out to the minion. It's going to grab all the facts that it found on that minion. It's going to be able to interpolate the templates, and that all happens out on the minion, and then it's going to run through that on the minion. Does that make sense? Okay. Gotcha. So that's your basic invocation of a playbook, and it does all that stuff. And we could, run the Ansible commands to go look and make sure memcached actually got run. What would be interesting is to do. Let's just do this real quick. Let's do a shell command. Let's do cat etc sysconfig memcached, just to make sure our template got interpolated. What do we got here? Oh, okay. Interesting. Oh, let's target that a little bit better. Instead of running that against all. Oh, that's what we've got to do. Ask. Alt. Pass. Again, it does that because it goes through those directories, finds, I've got group vars that match these memcached hosts. And here we go, we saw it got interpolated. Cache size, these things only about have half a gig of memory, or 600 and some on 690. Options -T1 because they've only got one CPU, and here's my secret that got interpolated, that got pulled out of the vault. Ta-da! Okay. There we go, woohoo. Okay, thank you for your prayers. Some other things I'm going to have you look up on your own time because we're about out of time is inside your playbooks you can put conditionals in there, which basically say don't execute this upon certain conditions, right? You can do loops, so you can say I've got this array of hosts, loop over those and do something. You can do includes, so you can break your tree up however you want. Full orchestration is really interesting. So I've got a playbook that I whipped up. I'll kind of run through it. It's kind of one of the last things we do. We want to go out and do this full rollout we talked about. We're going to update the database schema for every web server, 5 of them at a time, turn the monitoring off in Nagios for it, pull it from the load balancer, do a git update of the web root on the web server, run a test script against the web server to make sure it passes all its tests, put it back in the load balancer, turn monitoring back on, and then restart memcached on each memcached server one at a time. All from one playbook invocation. Okay? And we'll look at the playbook. I'm not actually going to run it. I'm going to let you figure out how to do that.
It means they have to have it in the servers.
That's right. Lastly, so prod rollout is what I call this thing. So this is kind of fun. So we've got on our database servers, this is the first play we're going to run, right? Here's the task. We're going to update the schema. So I'm going to use the script module, which is going to copy this script locally, and then we're going to copy it out there, and we're going to run it, and we're going to pass it the from argument. So we're upgrading our database from schema version 1.0, and we're going to version 1.2. And that's going to get run out on the database server. And we can tell it creates this file so that it's idempotent. We pass that so that command can be idempotent, right? So that if we run it over and over again, it won't re-update the schema and screw things up. Okay, so now we're going to do the web servers. We want to do the 5 at a time, so you pass this flag called serial 5, which says run this play 5 machines at a time. Whereas this one would have been run on all of them in however parallel you want. And there's an option to the playbook to specify what level of parallelicity, how's that for a word, that you want. This max fail percentage is interesting. This tells Ansible, it says, while you're running this play, if 20% of the hosts fail for whatever reason, just stop. If you get up to 20 or more percent, just stop. Don't do anything else, because something's horribly wrong. We don't want to keep beating the system to the ground. So in the task, we're going to remove it from monitoring. So we invoke the Nagios module. We're going to do the disable alerts action on that module. We're going to pass in the Ansible host, which is a discovered variable from the host it's running on. And we're going to delegate this task. This is a really cool feature. We're going to delegate this task to the Nagios host, which presumably we've defined somewhere, right, in our inventory. So when Ansible comes to this, it's going to loop through these 5 machines, right? And it's going to run this command. But when it comes to running this command, it's going to go out to the Nagios host and run it out there instead on behalf of the web server that it's running for. Yeah?
How do you know to use the strings versus not? Passing it as a string, delegate to as a string versus host as just being a template.
Oh, like this one and this one?
Mm-hmm.
This one I was just following the example, so it's a bit of cargo cult. Yeah, I'm not quite sure. That was just the example in the, yeah.
How does it, is it delegating using Ansible on the web service?
Yes.
So is that
No. The master's still running this, right? So it's got some kind of communication going back and forth between the master and the minion to know that when I get to this web host, and I get to this play on the web host, I need to run out to the Nagios host. At least that's how I presume this works. I never actually have run this manifest. It works in my head, so. So caveat executor, right? That's why down here at the bottom I say there's like a homework is to go out and your homework assignment is to go out and test this, okay? But they have examples showing that, and that's how I presume it runs, right? You've got some kind of communication happening between the master and the minion, and so the master knows that when we get to this point, very good question though. I'd be interested to see how it handles that.
Quick question. Do
Yeah.
you know CoreOS supported well with Ansible?
I do not. I'm not super familiar with CoreOS. My guess is if it's like popular and a lot of people are using it, probably so. I know they've got recent support for Docker and zones, that kind of stuff. Okay. So we're going to spin through that on all the web servers, remove all these 5 at a time from Nagios monitoring. Then we're going to remove it from the load balancer by using the Big IP pool member module. Now this requires some extra dependencies, Python dependencies on the master. And we're going to say this is your load balancer, which comes from a variable somewhere. You're going to log in as this user and password, which presumably we've got in a vault somewhere. You're going to run this against the web server's pool. I don't have any of you got F5 experience. And we're going to look for this host, which is the discovered IPv4 address of the web server we're running this thing on. And it's a pool member, so we've got to have IP address and port, right? Okay. And we want to make sure that's absent. Just yank it out. Yank it out of rotation completely. Delegate that to the local host. Run this module from the master. So the master is going to reach out to the big IP, pull that web server out of rotation, and then move on to the next web server. Okay? So we're moving it from monitoring, moving it from the load balancer. Now we're going to update the code. We just use a git checkout to do that. Restart your service. Do a reload on your service. Now run your test suite and run that on the local host. So from the master, you're going to hit your web server. Did it update? Did it pass all its tests? And then we're kind of do things in reverse. Yeah.
In terms of the Git, is there already the Git hook in there, or the hook receive, or is Ansible like replacing that?
I don't know. I'm not quite sure I understand the question.
This is doing a Git pull, isn't it?
Yeah, it's just doing a Git pull.
So still using the Git hook receive.
Yeah. And I assume that would all be local to that Git repo on the web server, right?
Yeah.
So if you've got hooks set up there on that repo, then whatever's going to happen. So then it's just in reverse. Once we've done all that, and then here's some more homework. Don't put that thing back in rotation if it fails the test. Okay. Then it's kind of reverse. We're going to make state equals present on the big IP pool, enable the monitoring again. Now that we've done all, and then it's going to do that 5 at a time. You remember, it's going to go through half of them, do the next half, and the next bunch. And then once that's all done, then we're going to come to the memcached servers, and we've probably got some data we don't want in the cache anymore. So we only want to do those one at a time because we don't want to like yank the whole cache and bring the whole site down, right? So we're going to do one memcached at a server at a time, refresh the cache, and we're done. Okay. So, like I say, it works in my head. Untested code, verify for yourself. But there's the promise there that you can do that kind of thing here. And the fact that you can reach out to load balancers, you can reach out to, if your network gear's there are Ansible modules that can support it. And you can extend Ansible, write your own modules. If you want to write your own proprietary code to reach out to these devices, use their APIs, you can do that too. Okay. So the demo's left as an exercise for the reader. Okay. Other stuff in the probably 0.5 minutes that we've got left. The recommended directory layout, don't worry about that. Just go to Ansible.com, you'll find it in their best practices section. This, again, if you want to scale up to being really sophisticated in how you're using Ansible, you can do that. Again, you can just use real simple playbooks. Yeah?
In their documentation, you talk a lot about roles. Have you used roles much?
I haven't in my use cases very much.
I found it difficult.
Yeah, for me too. I don't know. I kind of like things simple. That's why I like Ansible. So depends on what your needs are and how you want to use them. You can use them. The role, what he's talking about with roles, is breaking all this stuff up into all these directory structures like group vars, host vars, and so forth. I think actually I may have. Here we go. So splitting up things into group vars, host vars. You've got a global site YAML file for each of your different groups, and then inside your roles you can break down. Maybe we've got files for different tasks, different handlers, different templates, different files, and so forth. For every different role, and just allows you to modularize your setup as much as you want. There we go. If you want to extend it, it's got an API. Imagine using this thing from your code. You can do that. Okay. You can create, we talked about dynamic inventory sources. You can create your own modules. And then you can create plugins. So if you want to create your own connection type and run it over something other than SSH, you can do that. You want to create your own types of variables or filters or lookups, you can do that. It's pretty extensible.
Node.js API?
I don't know. I think it's a Python API because it's written in Python. But so this is me. I'll be putting my slides up at branchit.com. Feel free to reach out to me at my email address if you have any questions. Hopefully this wasn't too boring. But so far, the use case that we had at Adobe for using Ansible was we have a global Anycast DNS system. And the old process by which we maintain the configurations for all those machines was a royal pain in the rear end. And so I used Ansible to automate it. And so I used, templated generation of configuration files for the servers. It's kind of fun because I whip up a local invocation on the master of Logstash that's listening on a high port, and then as I go out to each name server and make the changes, I configure the remote logging configuration on those servers to log back to my Logstash. So as I'm reloading each server, I can be tailing the logs in real time of what's happening to be able to see them. So you can do lots of really fun stuff, and then I do all the name server stuff, and then I come back and shut down Logstash in a third way, right? So you can do all sorts of, it's whatever you want to do, right? You just, if you have different processes that are currently manual, that are step here, step there, step there, step there, you can do it. Yeah.
I moved from Puppet to Ansible, and I'm very pleased because Puppet was a pain.
One thing, I guess, for a lot of people, not having to memorize or learn some new language, domain-specific language, it's really approachable. The friendly names for your tasks, there's a lot of pluses here. I'm not saying Ansible's the be-all, fix-all. It fits for a certain niche and for certain situations. In other situations, Salt's going to be better. As you saw, the invocations can be sometimes a little bit slow. There's some things you can do to SSH in your config to speed that up. But it's probably not going to be as fast as, say, the message bus that you might find with Salt or something like that. But depending on the way you configure it, depending on your network, a lot of factors. Any other questions? I think we're out of time. Cool. Thank you.